Welcome to topic 2 of learning to code on the cloud. In this topic, we're going to talk about list and loop. So after the first two topics, we will have introduced the most important syntactic element. So at this point, we can write a lot of non-trivial program. In fact, we have covered enough to essentially write any kind of program. However, some of the program may not be very convenient to write. So the other syntactic element and data structures will help. So anyway, a loop is a very important concept, and I hope you are able to master this concept. So first, we're going to review the syntactic element of Python that we've covered from topic 1. So we have values. So because we use program to compute, when we compute, we get values, and there are different types of values. So there are numerical type. So we mostly using int, so integers, but we can also get non-integers, which are known as a float, which stands for floating point number. The name coming from historically how such a I guess this is that's called a decimal number. Such a decimal number is represented in computer. The method is called a floating point. So this is known as a floating point number, a float type. And we also cover string, even though not what we can do with a string. So we mostly just have string constants. So the topic 3 will talk about how to manipulate string. What are the methods that are provided in string? And also, there's this Boolean type, which have basically just two values, true and false. Arithmetic operators are used to operate on numerical types. So we use this to write expressions that can compute values. So we have addition, subtraction, multiplication, division, integer division, and mod. And there are a few other arithmetic operators we have not introduced yet. So for example, there's exponentiation. So we'll introduce it when we need that. We also have comparison operators. They can compare two values of the same kind. And the two values of different kind will just not equal. So when we compare, so actually let's check whether that's true. So if we just compare, say 1 equal 1, okay, so it's false. So that 1 equal 1, so this should also be false. Yes. So we actually can compare a value of different types, but they usually are just false. So by usually, I mean there are cases where I think this thing can actually be true. Yes. So because true in Python is actually represented as numbers. Yeah, actually as 1. So true actually equals 1. But you don't really need to use that, and I don't recommend your code relying on that. So most of the time, this comparison operator compare two values of the same kind. We introduce a 6, so there's equal, greater than, less than, and so on. And then there are logical operators which operate on Boolean types. So they are and, or, and not. And when you have a lot of these operators together in an expression, sometimes which goes with which may be not clear. So in that case, I recommend just use a lot of parentheses. So I guess until you're really fluent, don't worry about having a little bit extra parentheses that are not totally necessary. So also we introduced the assignment statement and if statement. So I assume assignment statement is a little bit easier to understand. So I just want to refresh everyone's mind about the syntax of if statement. So if has a condition followed by the body of the if branch, and then there can be 0 or more of this else if branch. Each of them have a condition colon followed by the statement. And finally, there can be an optional else branch. So it doesn't have to be there, but it can be there. to illustrate if statement and also to illustrate the importance of indentation in Python, Python uses indentation to tell where a block of code starts and where it ends. So in other programming language, for example, in C, C++, and Java, after you write this if statement, there will be an open curly bracket, and then there will be a ending curly bracket. So you know which part is the if branch, and which are the things that comes after the if statement. But in Python, we don't have those open bracket, end bracket. Instead, things are determined by indentation. So essentially, after the if statement, everything following it and are indented. These are interpreted as the body of the if statement. So if we write the code this way, then all of this belong to the if body. So if the if condition hold, we execute this. If the condition doesn't hold, we don't do anything here. So these three versions of the code, they are the same, except that indentation is different. So here, this else, instead of here, it comes to here. And here, the if, instead of here, it comes to here. So in fact, all three versions can execute because what Python expects is everything coming indented within this group. Everything with the same indentation belong to the same level, belong to the same block. But you can use the different indentation for different groups. For example, here, the if branch, the indentation is 4 white space. The else branch, I use 8, but that is fine. So because this starting a new block, Python just need to make sure everything here is consistent. It doesn't need to be consistent with there. So I want you to think about what should be the output if A is 2, B is 3, and C is 1. So for each of the three versions. So before you move on with the video, I recommend you walk through the code and come up with the answer first. Okay, so this is the output. The first version doesn't output anything because 2 is not greater than 3, so nothing gets executed. So the second version output 2 because this if will be false, then we go to this else branch because this else goes with this if. It comes at the same level. This else does not go with this if. So this if statement does not have an else branch. And here in this version, this outer level if statement does not have an else branch. So then we will execute print A, which give a 2. And here, because this if is here, then this start a new statement. So this if doesn't have a else branch and start a new if statement. Because A is greater than C, so this part gets executed. So print C got executed. So we see a result of 1.